It dropped by.
All right, on the start by, which one do you want to see go over? Have questions about? Did we have any questions on this? Right, if not. So we did the first three problems on this. Go to the back of this. And of problems 4, 5, or 6, are there any we want to see, go over, or do? Had questions about? You may have done that during practice. We only did the first three. They're not in the graphing notes, but in the solution notes. The ones that look like this. Of 4, 5, and 6, are there any we want to see or do go over how questions go? Taylor,
Can you go over 6?
using which method? Algebraic, graph, table.
Here.
Okay, so if you don't have your calculator, you need to go grab that. And then we're gonna put this into our y equals. Come on, still in grab your calculator. Great, so put your equation into your y equals. Those of you describing your calculator, go into y equals, type in number 6 is equation. Taylor, which one do you want to grab it? Taylor, okay. So second graph will get you into the table. We're looking for where the y-intercepts or the y values repeat in the middle of those. Where's the middle?
1 and 2.
1, 3. So you would put that in the middle and fill out the rest of your table. So then backwards we have 0, -1, -2, forwards 2, 3, 4. And then we have 0, -9, and -24. And then it repeats. We have to move from one to this one. And how is one? This is the only y value that doesn't repeat. So plot all of those points. Or whatever points you can. So really just these 4, because the 224 is way outside the graph. Okay, go back to your y equals, make sure you type in the 6 equation. How many solutions does this have?
Two.
Two, what are they?
2 and 0, 0.
So 0, 0, and 2, 0, yes. Remember, you can write them one of two ways, as order pairs or as a solution set. Can you do another one for algebra?
Sure, pick one.
Okay. For 5, do we have a B value?
No.
No. So that means this is just gonna become 0. If I put 0 back in. What would the Y value be? That's B. You don't have a variable with just X. So what would your Y value be? 1. So your ordered pair in the middle would be 0, 9. And then, even though you did the first part algebraically, I would recommend doing the second part either in your graph or in your table. You can fill out your X's, so go backwards. And then, if you wanted to do it algebraically, you could. You would have to put each of these values in for this and figure out what that would mean. So I'm gonna just put it back into Y equals and go to the table. And fill out those ones. So 8, 5, 0. And then it reads. So I would plot all those ones. How many solutions does that one have? 2, and what are they? -3, 0.
Yeah.
And what's the other one? Yes, David.
On the test, do we have to do anything algebraically, or can we just do everything like?
You can, it's your choice. So as long as you tell me how you found it, that's fine. And for this objective, the graphs will already be there. You'll just have to find the solution. It's just extra practice to graph right now. Okay, once you have that written down, go ahead to the next page. So this page is going to help you do the 2 Khan Academy quizzes. So first, the most helpful thing with this is to find your solution. So these are graphed already, find what your two solutions are. What would those 2 points be? Or what are the values of those 2 points?
Or negative.
-4. And what was this one? 2. But when we write the roots, it's gonna be opposite, kind of like our vertex form. So whatever this says, you're gonna write the opposite. So this would be x minus 2. This would be x plus 4. Now, this next part is not something we need to do, but it's good practice to make sure that you got the right things. If you wanted to see what this overall equation would be, you could distribute it. So we have x squared times 4x, or plus 4x, sorry, minus 2x minus 8. And then we would combine like terms. And if I graph that equation, it should end up the same as this. So this and this are really the same. This is just in factor form and this is standard form. But what you'll need to be able to do is you won't be given this part, you'll be given these and have to find these. So how you would do that is take each factor, set them equal to 0, both equal to 0. So write that off to the side somewhere. And solve. So to check yourself, you could graph it, make sure you have the right zeros or roots or solutions. If you are given something that's just x minus a number or x plus a number, you don't even have to really do the work because it's going to be the opposite every time. There will be some examples that are not the case, and I'll show you those. Before we do another, do we have questions on that? So what would the two solutions here be? Kind of blurry, but they're really close together. Mhm. If I just put those both in factor form, how would you write that? It's always opposite in factor form, but when you solve it, you'll get the actual. So we don't have to do the next part, you can if you so choose. Three, what would your solutions be?
Negative.
If we were to write those in factor form, how would we write that? Plus 3x plus always opposite. Doesn't matter the order. Right, and then 4. What are your zeros or solutions? -5? Positive 5. So then how would you write those in factor form? How's it look like these? X plus 1 and x minus 5. So I'm going to show you what, yeah, it doesn't matter. I'm going to show you what some of the Khan Academy questions are going to look like for the ones that are due this week. You can put this in any blank space you see in your notes. We'll do one of each. So some of your questions in the zeros of polynomials factor form, they're already going to be in factor form. They're going to tell you what the zeros are, and you have to figure out which ones those would be. So the ones that are just whole numbers, those are going to be the ones like we just did, but opposite. So which of these two, C or D, would match these two? D, because it's opposite. So then nothing else really matters because it has to be D. But to figure out the other one, you could take this, set it equal to 0, and solve. And you should get this in. So as long as you know what the zeros are and how they would look in factor form, you'll be fine on that. The other one is very similar. Except they give you two that you have to solve. They won't give you the answers already. So this one we know without really solving that it's going to be the opposite. It's going to be +3. The other one you may need to solve. So set it equal to 0 and solve for x. Then x equals a +4/5. Then lesser is whichever one is smaller. Could be negative, could not be, just whichever one is smaller, and then greater is whichever one is bigger. So 4/5 is smaller than 3. I'm sure you can't see that, but I did type in 4/5. So again, as long as you know how to solve them and what they would look like in the opposite format, this should be fine. You should be fine. But if you have questions while you're doing this, let me know. Okay, questions on Khan Academy stuff? We're gonna start the last set of notes and then finish it next class, and then this will be the last thing we do today. All right, so this is our last lesson in quadratics. So we've talked about how to solve by square root, how to graph them, how to find the solutions. Now we're going to talk about a different way to solve, and that's using the quadratic formula. We factored last unit. Factoring is another way to solve quadratics. But we are not doing that in this unit, just like the end part. And then this is more so when you can't factor. Yes. I did not. That's this one. You're right. So when you can't factor, this is what this would be used for. Those of you going on to algebra 2, you'll see the quadratic formula again next unit. They'll have you actually memorize it. Memorizing it now would be beneficial for you, but if you don't, it's always hard. So we're going to do the example first and then do a couple of problems depending on time. If you need more space, feel free to grab extra paper. So first things first, I would label which ones are which variables are which, or coefficients are which, I should say. So your A, your B, and your C. That's going to be helpful for when you start putting things into the formula. And really, it's just put it into the formula and simplify. So we have x equals negative b plus or minus the square root of b squared minus the 4 is always there times your a value times your c value all over 2 times your a value. So the negative b and the 2a part, that's the same as before, finding the axis of symmetry, but, and you'll learn this later, this is called the discriminant. That part isn't. So once we have all of that written down, we just start to simplify. So at first, we're going to do each thing step by step, and then once we get more comfortable, we'll be able to skip some steps. At each step, you need to have x because it is an equation. This will become a positive 6. We need to keep the plus minus, keep the square root. This will become a positive 36. And you can multiply all of these at the same time. So negative 4 times 1 is negative 4. Negative 4 times 4 is negative 15. And 2 times 1. So it looks a little simpler, but we have to keep going. I may need more space because I'm running super good. Subtract what's inside the square root. Did I do that math right? I think. And then look and see if this is a perfect square or not. So if you're not sure, you can go to your calculator. I hit second mode to get out of that. And then second x squared will give you your square root. And you can put that in. If you get decimals, you can leave it on. When I show you how to do the Khan Academy next class, I'll show you how to change it. So we can't, in algebra 2, you can simplify this, but we're not going to, so this would stay the same, but you would have two answers because of the plus and minus. In set notation, you would separate this. 6 minus the square root of 20 all over 2. And 6 plus the square root of 20 all over 2. If the square root of 20 was a whole, not whole number, perfect square, like 16, 9, 4, 25, any of those, then we would have simplified that and been able to simplify these terms. But if not, you would leave it like this. Questions on that one? Okay, let's do another. So your first thing should always be label your A, B, and C. The formula is the same, it will not change. So we would do negative B, x equals negative B. Plus or minus the square root of B squared. You can put the parentheses, you don't need them for this one since it's already positive. Minus 4 times A, which is 1, times C, which is negative 2. All over 2 times A. Then we can start to simplify. Negative 10 plus or minus 10 squared would give us what? 100. Negative 1 times, sorry, negative 4 times 1 times negative 2 is what? Positive 8, because we're 2 negatives, yep. Simplify that. Is the square root of 108 a perfect square? Will you get a whole number? So no. So because of that, we would just separate it. Negative 10 minus the square root of 108 all over 2. And negative 10 plus the square root of 108 all over 2. Questions on that one? In number 2, this is not in the same format. These need to be equal to 0. So anytime it's not, you're going to move anything over so that it's on the same side. So get rid of the 4x, subtract it to the other side. And then I put the 4x in the middle because that would be your standard form, ax squared plus bx plus c. What would be our next step? What's the very first thing we do before we start this process?
That's A and C, right?
We have all 3. But we would label them. And then we can start this process. X equals negative b, but it was already negative, so make sure you have both, that way we can change it. Because it wasn't equal to 0. Plus or minus the square root of b squared, so I would put that in parentheses. Minus 4 times a times c. All over 2 times 2. Start to simplify, so we have positive 4 plus or minus the square root of, this becomes positive 16, this becomes a positive 44. 16 plus 44 gives us what?
Is 60 a perfect square? Will you get a whole number?
No. So we would leave that as is, but separate it. 4 minus the square root of 60 all over 2, and 4 plus the square root of 60 all over 2.
Wouldn't that be negative 16?
There's the negative times the negative.
So that would give you a constant.
Whereas
In example 3, we'll actually get whole numbers.
What would be our first step?
Because it's not equal to 0, so you have to get it equal to 0 first. Label your A, B, and C. Then we can start our process. X equals negative b, but it's already negative. Plus or minus the square root of b squared minus 4 times a times c. All over 2 times a. Then we can start to simplify. This becomes positive 8 plus or minus the square root of 64 plus 80 all over 2.
64 and 80 gives us what?
$144.
Is 144 a perfect square? Yes, and it would give you what?
12. So this is when you would have to simplify more.
Because now you have whole numbers that you can keep going.
I'm running this. I'm gonna just put this off to the side. So we would still separate this into the two. X equals 8 minus 12 over 2. And 8 plus 12 over 2. but then we would have to do both sets. 8 minus 12 would give us a -4. 8 plus 12 would give us 20. And then we could divide both. So we would end up with -2 and 10. Doesn't matter what order we're in, least to greatest, always. What questions do we have on that? Yeah, did you make it faster? So we're gonna do a couple more and then we'll stop for today. We're gonna do 4 and then we'll do 5 and then we'll hold off on any you guys want to see, go over, do until next class. Alright, so number 4, let's do the same thing. This is equal to 0, so we don't have to do anything except label. So we have x equals -b, but it's already negative. Plus or minus the square root of b squared. Keep that in parentheses. Minus 4 times a times c. Notice I'm saying the formula and not what the actual things are, so that you get in the mindset of knowing what those things are. So simplifying, we have x equals 5 plus or minus 25 plus, what's 4 times 36?
1.4,
1 what?
44.
Okay. Which, we have that first. 25 plus 144 is what?
160.
It is 159 a perfect square.
Fifty.
13. So we have x equals 5 plus or minus 13 all over 2. Separate them. So 5 minus 13 all over 2 and 5 plus 13 over 2. After you've separated them, if you want to put each fraction in the calculator to solve all at once, you can do that, or if you'd like to see each piece, you can also do that. We have 5 minus 13 would give us -8. Thank you. I was like, my brain is not. 5 plus 13 would give us 18. So what would our solutions be? -8 divided by 2 and 18 divided by 2. -4.
74.
None.
So you simplify the word more.
That's it. The ones that you get whole numbers, that means those probably could have been factored, but we're not solving by factoring. Questions on 4 before we do 5? 4, 5, let's do the same thing, label them A, B, C. Start the process, x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Start to simplify. We have 36 minus 40 all over 2. This would give us a -4 over 2. Do we remember what happens when we have a negative in the square root? You can't hit the square root. We'll get an error. So it's no solution. So if you get a negative underneath the square root, first double check your work because you could have gotten that by accident. You could have missed the negative or multiplied incorrectly. But if you get a true negative underneath the square root, once you get to this step, you're done. It's no solution. We can't solve it. Or we can't end this class. You will be able to in algebra. Questions on this? So Friday, we're gonna do more examples on this. Whatever questions you guys want to see, I'm gonna show you how you would do this on Khan Academy. But for the remainder, and I'll give you your review on Friday. For the remainder of class today, you can be working on this practice, on your solution practice, on your Khan Academy, this due Friday, pass, any of those, and let me know if you need my help or have questions. Use this time wisely. If you want to finish your test, you can also use this time, but you have to come see me.